one of the things that is very important at the DOE labs, and I think in industry and academia, is collaboration and teams, particularly when those teams are very large. So you're seeing today one example of a very large team that's spread across lots of different institutions. And so what are the dynamics that help make that work and not work? And so we'll talk a little bit about that later in the talk. But first I want to talk a little bit about the Department of Energy. So I'm not sure how many of you are familiar with its history and the fact that very large teams have been an important component of the Department of Energy's work since its inception, even before its inception. And so this actually was started way back in the 40s as the Manhattan Project, as many of you know, where folks were trying to figure out, basically how to build a nuclear bomb. And so there were teams that were formed in Los Alamos and in California that were focused in Chicago and a lot of different places around the country that were focused on different aspects of that problem. And so there were very large teams then, so I'm going to need to put on my glasses here. In the 30s and 40s, where you looked at maybe 130,000 people who were all really vectored at the same big picture problem, subdivided into smaller teams looking at smaller problems. And so after the Manhattan Project finished, it went into more of the Atomic Energy Commission years, so this is in the 60s and 70s, where they started to look at different parts of the problem. So instead of looking at fission, where atoms are splitting apart, they wanted to start to look at fusion as well, where atoms come together. And so I think it was 1951 when they started and initiated a research program in fusion energy sciences. And so how many of us still hear, fusion energy, it's only 10 years away? It's been that way since the 50s, right? And so it's, and now that's culminating, of course, in the large ITER facility that's being built in France that will, hopefully for the first time, demonstrate an energy gain in fusion processes. And we're very involved in that in the Department of Energy. Another big area that they researched in the 60s and 70s was looking at the effects of radiation. And so this actually led to trying to understand the impact on human health, what various different radioisotopes did, how they could be used, and that led to, for example, clinical machines that are used every day. When you get your teeth x-rayed or x-rays of your bones, those kinds of things came out of this kind of research. And then I don't know how many of you know when DOE was founded. It actually wasn't founded until the late 1970s, 1977, when there was an energy crisis. So if you remember back in the Carter years, right, there was, huge problems with petroleum, and so they really wanted to start to broaden the mission of the Department of Energy to look at things above and beyond gasoline, right, and nuclear weapons. And so they really wanted to deal with energy policy, start looking at renewable energy, how do we manage and control our fossil energy resources. And so all of those programs were developed and started in that period of time. So the DOE lab system is actually fairly extensive. There are 17 labs in the DOE system, and they're all around the country. So here's a map of where those labs are. They're run by different parts of the Department of Energy. The Department of Energy really has three basic components for those who aren't familiar with it. There's the DOE Office of Science, which is the part of DOE that runs, for example, Argonne, and also Oak Ridge and Lawerence Berkeley Lab. They in fact run 10 of the national laboratories around the system. Then there's the National Nuclear Security Administration, NNSA, which runs the National Security Laboratory. So that's Lawrence Livermore, where I work, which is in the East Bay area. A number of you have asked me where is Livermore, so it's near San Francisco. Also Los Alamos and Sandia National Lab. And then finally the applied energy offices, and there are several of those. Many of them have laboratories associated with the work that they do. So fossil energy, renewable energy, nuclear energy, a lot of those different components of the DOE program have laboratories, and these laboratories do tend to work together to solve very, very large problems that are important strategically to the national mission. So even today, the Department of Energy is extremely reliant on large teams. So many of you are hearing more and more about the large compute resources, or already know about the large compute resources that we have at the Department of Energy. And that's actually something that has been part of the lifeblood of many of the laboratories, since the very, very early days of computing, the 50s and 60s. There's a chart we often use at Livermore that shows how we've been involved since the 1950s in the latest and greatest computer architectures, and I think many of the laboratories have those equivalent charts for their laboratories. And so we do have leadership class computing facilities, but we also have a lot of large experimental facilities. So I don't know how many of you know the statistic that the Department of Energy claims to fund the most physicists of any organization in the US. And I don't know how many physicists that is, but it's a lot of them. They're all running around the laboratories doing really good science on things like the Advanced Light Source, which is providing really, really bright X-rays to take pictures at the molecular level of various materials and to understand those molecular structures and maybe even the dynamics of the molecules. So there's lots of different facilities that are out there that require very large teams to build. So for example, the large facility at Livermore is the National Ignition Facility. It's a very large laser facility that has, it's basically the size of 3 football fields, and it's got 192 laser beams running around, all focused in on a target that's the size of your little finger. And what they're trying to do with that is create the conditions of a star inside the laboratory. So as you can imagine, that little target is encased in a very large sphere of big metal, which is encased in a big concrete room, just in case things don't go so well. It's never gone bad. There's a shot a day now. So, but again, that took 10 years to construct, hundreds of people, very large budget, and now there are science teams from around the world using that facility to perform science under very high energy, high density conditions, right? And so there are lots of different examples of this. I mean, there are several that are mentioned here. For example, we use computing as one way to help design much more efficient combustion systems. So that's work that's done at Lawrence Berkeley Lab that you'll hear about tomorrow, the structured AMR. There's a code that we'll present tomorrow called BoxLib. I think Brian will talk about it a little bit tomorrow. That's been used in trying to design low NOx fuel injection burners. And so the computing can be an important part of all of these different kinds of models. Climate models, everybody's aware that climate modeling is a big scientific computing problem. I mentioned it this morning, lots of different physical processes blending together. In fact, there are new programs that are just being started by the Department of Energy's Biological and Environmental Research Office that are investing $20 million a year in the next generation of climate codes because it's so important to the energy policy to understand what's going to happen to the climate. So the current funding emphasis in the Department of Energy continues to really be focused on large teams. And so you're seeing an example of that today with the FAST Math team. As you saw on my list of investigators, we have probably 40 to 45 investigators working together to advance the goals of the scalable libraries in mathematics for the SciDAC program. There's another large center called SDAV, which stands for Scientific Data Analysis and Visualization, I believe, which is equally as large. It's probably got 35 to 40 members associated with many different, and I think that's part of this program as well. You'll have some visualization experts here. Has that already happened or next Thursday? You'll probably hear from folks who are associated with that center as well. In mathematics and in software productivity, there are lots of efforts that are focused on integration across the DOE laboratories, bringing different capabilities together. And of course, on the NNSA side, we have to work to certify the stockpile every year. So one of the things that our lab director does is he writes a letter to the president saying our stockpile is safe and it's secure. And we can't do that anymore with underground testing. That's been banned since the 90s. And so that's all done now with computational techniques. And so there are large codes at each of the NNSA laboratories that are focused on those kinds of physics. And then moving to the next generation of architectures, we heard about the challenges associated with that. We have a very large effort now at all of the laboratories focused on taking these big multi-physics code and moving them to the next generation of machines. Similarly, in the applied energy offices, there's lots of different large teams that have been formed. Things no longer happen necessarily at a single laboratory. So there was a recent effort that's focused on nuclear energy called CASTLE that involved collaborators at Oak Ridge National Lab, Sandia Lab. It was about $25 million a year. I don't know if folks remember the hubs that the Department of Energy Secretary put out. It was it 4 years ago, 5 years ago? This was one of those hubs. And it was really focused on accelerating how fast technology could get out into the world. I was involved in a nuclear energy initiative, which was focused on advanced modeling and simulation. They really wanted to do something similar to what had been done with the ASCII program for nuclear weapons in the area of nuclear energy. And so they put together a program that started at about $20 million that had a lot of different teams involved, all the different laboratories. It did get whittled down to $13 million over time, but it was a nice example of teaming in the environment. And I already mentioned, for example, the climate modeling for energy at about $20 million a year. So why am I talking to you about this? So why me? So I've been introduced twice, so let me introduce myself a third time. So, I mean, you've seen some of the experiences that I've had. So the Fast Math Institute, it's been going on now. We're in our 4th year. We'll be completing the project. It was a 5-year project next year. And as I mentioned, it's a 45 member project that's focused on a wide variety of applied math topics. The Center for Applied Scientific Computing at Livermore is a research organization in our computation directorate. We have about 100 PhD level researchers who focus on applied math, computer science, and data science. And all of those folks work in large multidisciplinary teams, either within the context of our laboratory and the programs to support our mission, or in the context of, for example, Office of Science applications or other applications with our industrial partners. Before that, I led a predecessor SIDAC project. In SIDAC 2, it was called ITAPS. It was about a 20-member team, and I was involved in the NEAMS project, where I particularly focused on the enabling technologies component of that. What kind of high-performance computing needs does this program need? What kind of libraries? How can we help meet those national needs for that program? And so one of the things that I have seen over the years is dysfunctional teams. And not this is a great team. The Fast Math team is a great team. We are not so dysfunctional. But you can really, I'm sure you guys have all been involved in teams, even if it's for small projects at school or larger projects at your workplace, where the team environment is not healthy. And you know how destructive that can be to morale for the project. You can see how it can really create problems in terms of meeting deadlines, in terms of trust. So there's all kinds of ways that you can tell that a team is not functioning well. And so, here's a list of those kinds of things, right? They don't talk much to each other. They talk more about each other, right? That's not a good sign. If you never address problems or conflicts as they arise, if you allow them to fester, that's something that can really lead to bad feelings. Oftentimes there are, everybody wants to do the best they can. In my personal experience, it is rare that somebody is actively trying to disrupt a team. Most folks in the environment I've been involved with, and I know there are exceptions out there, really do have the best of intentions, right? They want to move the project forward, but sometimes misperceptions or misconceptions are born, which leads to mistrust. And if it's not discussed, if it's not aired, that can only fester and get worse and worse and worse. So lack of taking responsibility for what's happening on. Everybody passes the blame from one person to another person. If things aren't going well, it's not my fault, it's Susie's fault, right, or whoever. Recognition is an important component of a functional team when things are going well. If only the leader is being recognized for the things that are happening well, that's not a good sign. And most leaders, we have a lot of leadership training, they know very well that they should be passing that recognition along, because it builds a lot of resentment if folks aren't getting that recognition. So in the contrast, things that make, a team great, right? So it's really basically the opposite of everything I just said. So if you have a lot of trust, if you have everybody feeling like they can express their views without being punished, if you have respect because people understand what everybody is bringing to the team, you have a much more high chance of success in terms of bringing this project to a successful conclusion, to having a healthy, productive working relationship with the team around you. So a really important component to that, as I've mentioned, is positive conflict resolution. So being able to air things in ways that may even get emotional, but to be able to do that with knowing that you won't get punished for doing so, either by other team members or by the boss or whomever, right? Being able to express your concerns openly is an important part of having a functional team, because there are tensions that are going to arise. You know, with every set of close relationships among different people, we have different things that we value, different things that we bring to the table, and those things aren't always in perfect harmony. That's something we all learn in our marriages, right, for those of us who are married. Commitment, making sure that you understand that the team's goals, the project's goals, are maybe more important than your own ego, right? So being committed to the team, being committed to the project. Attention to results, making sure that you deliver on what it is you've said that you're going to do, that you are contributing to the team in ways that are right for you, that help the team move forward. So those are all things that need to be done in order to have a successful teaming environment. So this is something that I came across several years ago when I was doing research for teams and other talks of this nature. So the concept of emotional intelligence, I think it's fairly well known now. It was, I think, a little less well known when I first started talking about this. Has everybody heard of this idea of emotional intelligence? Your emotional IQ, as it were. So basically, it's about being able to understand and recognize the emotions that are going on around you, and then being able to harness those, so to speak, for the good of the project. And those can be very positive emotions, but also negative emotions, right? And so being able to recognize what's going on and not just be oblivious. So we all know some folks who are probably oblivious to what's going on around them emotionally. They're maybe very, very smart people, very intellectual people, but they've missed the fact that, there's a person crying, in the chair next to them, right? Or whatever it is, right? So just being attuned to that is a skill that you can develop, and it's about reading faces, right? And understanding what's going on, or understanding tone of voice or body language is a huge part of how we communicate, and a huge part of how we transmit our emotions, whether we're feeling very positive and powerful, or, confident. You might stand like this, right? I'm positive and powerful and confident. Or if you're feeling kind of defensive or closed off, oftentimes people do this, right? And they shrink down. And you can notice those things and learn to notice them. And that can help you with your emotional intelligence. So they talk about this as being a very, very important component to team dynamics. So teams that have high emotional intelligence tend to do a little bit better because they're not oblivious when something is going wrong, and they can address it early before it starts to fester and get problematic. So they suggest all kinds of different practices. It says 3. I see that there are actually 4. So I know I'm a mathematician. I don't count. But there are lots of things that you can do, right? So we talked about this a little bit, making sure that team members have time to appreciate each other's skills. So they suggest, for example, starting a meeting with a few minutes to reflect on, here's what I accomplished in the last week. Go just do a round robin around the table. This is what I accomplished last week, so that everybody on the team can hear what it is everybody's been accomplishing, so they can appreciate it. They understand the skills that people are bringing to the project, and don't just think that, Hannibal, or maybe not Hannibal, but we'll go back to Susie, isn't just sitting around doing nothing, right? This is what she's bringing, and this is what she's contributing. So we talked about the emotional issues that can hinder a team's progress quite a bit. There are lots of ways of regulating these kinds of emotional issues, and in ways that can be fun. Using humor to diffuse situations can often be productive. They had one suggestion in here, this regulating unwanted behavior in productive ways. Their specific suggestion for that is if you're doing a brainstorming session and you want to make sure that ideas don't get judged too early, which is an important part of brainstorming, you give everybody soft toys. And then if somebody starts judging an idea too early, you're allowed to pelt them with a soft toy, right? And so that's a fun way of kind of regulating behavior that you want to discourage, right? It's funny, people laugh, it releases tension, and it lets folks know you were judging there a little bit, right? And then showing appreciation. This goes back to the boss or the project leader who doesn't give recognition to the folks who are doing a really good job. So you really want to celebrate those successes and make sure that everybody's aware of what the successes are. So I think that in the DOE, and we've mentioned this a little bit, there are lots of challenges to creating these high-functioning teams. So we talked a lot about things like emotional intelligence being an important component of this. It's really hard to have emotional intelligence through email. I mean, email is kind of a disaster, texting the same. So these electronic communication devices, so what do they say? The words we say are about 7% of our message. The tone of voice we use is about another 25 or 30% of our message. And then our body language is the other 60 to 70% of how we are communicating and how people are perceiving what we're saying. So it's not just the words. So even phone calls can be very, very difficult to interpret because you can't see a person's face. You can't tell if they're being open. You can't tell if they're trying to criticize. It's just very, very difficult to gauge sometimes just based on words or words plus tone of voice. It's very difficult. And so these geographically dispersed teams create a lot of challenges, not just with logistics of setting up a teleconference time, but also just from the communication aspects of it. I would say in the Department of Energy, a lot of today's current teams have a pretty strong history of actually being quite competitive with each other. Back before large collaborative teams were part of the norm. And so you can see many of us are of a generation, say in our 40s or so, where before SIDAC, we were actually competing a lot with each other in terms of getting proposal or grant funding from DOE's Office of Science or other agencies. And so there were a lot of hard feelings that were created that way. And so yesterday's competitors are now our allies. And it takes a little bit of time and energy to get over some of the emotional challenges associated with that history. Another area is, we talked about emotional intelligence, compatibility, having personalities that click, right, and really work well together. You've probably seen some of the articles about Southwest, and they don't really hire people for their expertise or their skills. They actually often hire them for their attitude, right? And they say, they're going to learn the skills, and that's how Southwest has been so successful. I've seen video after video on the fact that really hiring for the right attitude is really important. And I look for those things when we're hiring people into CASC. I look for attitude. But oftentimes on the teams that we're forming, expertise is much more important necessarily than the compatibility of personalities or even attitude. And so sometimes you end up with situations where you've got personalities that just don't get along, never get along, and you're going to have to figure out how to manage that situation in ways that are productive, even though you couldn't necessarily hire for that cultural bias that you wanted to create in the team. So let's see. Oh, this is, yeah. Everybody at the DOE labs will know what I'm talking about here. So team members are parts of many, many different projects. So Rob, how many projects are you involved in? Yeah, 7, 10, There's a lot of different projects that folks get involved in, particularly as they become more and more senior and their expertise is more widely used. And so they're split in a lot of different directions. Sometimes it's difficult to get them to get focused time to perform well on a team. And so that this tends to lead to a little bit of a lack of team identity. It leads to conflicting priorities that folks have. Do I work on project A or do I work on project B, and in what time frame? And so a team lead has to be able to try and manage those sorts of things to create a functioning team. So from my experience in the SIDAC program, so I've been involved in SIDAC since its inception, so I've been involved for about 15 years now. Here are some of the things that I think are critical to making a team work. So I think occasionally, as often as you can, you need to have face-to-face meetings. I would say this is something that was a little bit easier in the previous rounds of SIDAC where the teams were a little smaller. We only had 20 people we needed to bring together. Now that I have 40 or 45 people to bring together, and I think about a 2-day meeting, it occurs to me, well, that's going to cost the Department of Energy something like $50, $80, $100,000 for all the travel, for the people's time. And so you really have to take advantage of opportunities to get together like the SIAM parallel processing meeting we were just talking about, the SIAM meetings for ad hoc face-to-face meetings, and make sure that your face-to-face meetings are going to be useful and well, a good use of time, because it can be expensive to bring these large teams together. So the informal interaction time. So in our kickoff meeting with FastMath, we had been bringing together 3 teams that had previously existed. So the ITAPS team that I was leading, the AppDeck team that was focused on structured gridding technologies, and then TOPS, which was a solvers team. We were bringing them all together under one umbrella. People knew each other some, they didn't necessarily know each other. So at our kickoff meeting, I made us do a social activity. And I have to say, the resistance was high, very high. It was basically write down, if you were not a scientist, what would you be doing instead? That was the question. And then we typed that up, and then at the dinner that night, we had people go around and ask questions. You can't say, would you have been the carpenter, or would you have been the truck driver, or whatever the answers were, but ask questions about the people to get to know them a little bit better, what other passions they may have. And afterwards, I actually got a lot of compliments that it was really fun, and people enjoyed doing it, even though when I suggested it in the morning, the groans and the heads on the table, oh my goodness. So those informal interactions, I think, are really important. So let's see, regular communication among the team with telecons. So I think this is important. I will say this is challenging for a very large team. So when I have telecons with the full team, all 40 people on the line, and I'll ask a question, it's amazing how quiet it is out there in the world. I mean, I hear the crickets chirping away in Chicago, even though I'm in California. So I think telecons are a challenge when you get to have too many people on the line. And so I haven't done it as much in this project as I did in previous projects where the teams were a little bit smaller, because for me, it was hard to figure out how to make that really effective. So yeah, don't become a bottleneck. If you're the project lead and every decision goes through you, eventually you will become a bottleneck. And so you need to empower decision making at lower levels and enable the folks who are working with you to make the right decision. Let them know what the goals are, let them know what the vision is, but then make sure that they're enabled to make decisions at that local level. Externally driven deadlines to create more of that team dynamic. So this tutorial, when we first had the opportunity to do this 3 years ago, I was so excited. And actually Barry and Lois were key drivers back then to really bring the team together and really push it forward as a team activity. And I think this has actually really helped the Fast Math project with our software technologies. Mark Miller's, who you'll see more later today, has been instrumental in making sure our technologies are working well together. And this tutorial has been a key component of that because it drives a deadline. And that's really important for our dynamics. Let's see, reward and compliment team success. I want to tell everybody today, you did a great job. And then open to feedback. So as a leader, one of the things that I think is really important is if something's going wrong with what you're doing, you need to be very open to hearing it. And not everybody is. And sometimes it's hard to get that constructive criticism. And for those of you on teams, it's hard to give that criticism of your project lead. But figuring out ways to do it that are constructive, I think is really important. And most folks really value that feedback when they get it. I don't get as much feedback now as I used to. I used to get a lot more feedback in my life. And I do value the feedback when I get it because I personally always want to be growing and improving and becoming better. So what didn't work so well? So telecons without the face-to-face meetings. So even with smaller teams, if you don't know each other, it's so hard to interpret what people are saying. If you don't have that trust that comes through face-to-face meetings and getting to know folks, I think telecons don't work very well. I think the informal interactions are very important. So without that interaction time, people don't get to know each other, they don't build that trust. And trust is, I can't say how important that is. Say enough how important that is. The lack of communication, allowing conflicts to fester, and then, the centralized control. So all of these things I've mentioned in the previous slide. So just to conclude, I think, functioning teams are really essential to DOE success, but also to the success of probably all of the projects you're on at universities. Again, it's much more important to be in multidisciplinary teams in many universities these days. In industry, teaming is a very, very important component of what we do. It's very hard to imagine being able to tackle a problem at the scale that we do as a single person. You just can never know enough about the physics, about the math, about the computers, about the the software. You'll never know enough as a single person to do that. And unless you're a physicist, so I hear from the physicists. So I apologize to any physicists in the audience. You really do need to work in multidisciplinary teams, and of course that takes all the things that we've been talking about, the trust and respect, the accountability, the appreciation, and the emotional intelligence. So I'll just conclude with some fun things. So I came across this Dilbert, and I thought it was highly entertaining, so I'll give you a chance to read through that. So, letting folks know what their responsibilities are, critical. Hard to be an effective team leader if you don't know that you're leading the team. I have a couple of videos that we tracked down. The links are still active. So this is a video of a team that is working well. Wow. Teamwork, success. They have achieved their goal. And then many of you have probably seen this video, but I just love this. So this is from Pixar. And I'm sure there are copyright violations that I'm violating by having this filmed, but not communicating well. And I never see this kind of behavior on Fast Math, by the way. You can see some of the things that I talked about not going well happening here. So they're not working together, but not for the good of the whole team. Okay, so that's all I had for this evening. Yeah, I'm happy to take questions, or if we need to get back up. Yes?
I have a question about collaborating through emails. Mm-hmm. So there are many times that whenever I send out an email to my collaborators, and then they disappear.
Yeah, in the ether.
Yeah, and sometimes when I send an email saying that you should do this or do that, and he said that, okay, I'll do that, and then disappear. So what do you do? What would you deal with these people, and how many times that you should poke so that you are not too naggy?
Right. I mean, part of this depends a little bit on your position, right? If you're in the position of authority, or if you are not in the position of authority. right? So, not actually, no, as it turns out. Yeah. I do have a list of people who don't necessarily respond. So yeah, so my approach to this has changed over time as I've increasingly had a little bit more authority to ask for things and set deadlines and make requests. I think part of it is if you can. Email does go off into the ether, and oftentimes it's not even necessarily an intentionally bad thing. They're not trying to be disrespectful, but what happens are folks are very busy and it floats up. I know this happens to me all the time. It floats up and off the inbox and out, and then it's forgotten. And yeah.
One thing I've found is when you appeal to a group, everyone in the group thinks someone else is going to respond.
Yes.
So when you really want an answer, appeal to one individual, and then if they don't have it, then go to the next.
Yeah. An individual by name, but it sounds like that's a little bit what you were doing. So the email is one mechanism. I don't know how comfortable you are calling them to remind them, asking them, if they're amenable, if they're they want to be helpful, right, and they're not doing it in a way that's destructive, but they've just forgotten or something, suggesting perhaps they put a reminder on their calendar. For example, I now have started to do that, so I don't just forget, because that happens to me a lot because I'm busy, and so things just are up and off. And so oftentimes it's not malicious, and so don't, going into it knowing it's not malicious, it's just busyness or forgetfulness or whatever, and trying to help devise strategies. How can I help you achieve this goal, right? Should I call you with a reminder? Do you want another email reminder? Can we put it on your calendar? Seeing if you can work with that person, if you're not the person who's in a position of authority, to figure out what works best for them so that you get what you need if they want to in fact be helpful.
What about collaborative tools, both for scientific collaboration as well as on the project management side?
Mm-hmm. Yeah, there are lots of tools that exist that people have used. I'm not going to go through the list of them here.
But what would you recommend? Because especially that for the two, there should be some distinction, some difference, because one is productivity, the other one is more management and more of a hierarchical.
Yeah, so I think like I said, there are lots of different choices that folks can use. In fast math, we have for example, for team activities that we do, we have a big repository that everybody has access to. So for one of our deadlines every 6 months is writing a big project report. So tools like that for the collaboration part of the project I think are absolutely critical. So shared repositories. We have the Redmine site that Mark set up that I think has been very helpful for managing, for example, some of our software and some of the management tasks that we have. When we have telecons, Mark's absolutely fantastic at taking notes and then posting those so that we have reminders. There are various to-do list type tools that you can leverage and take advantage of. So like I said, there are lots and lots of different sites. What we're using on Fast Math is basically the shared repository and the wiki site for the most part. Those are our main things.
They're of value, but I can find a carpenter and give him the best tools in the world, and he can still make a piece of crap. I can find a carpenter and give him 100-year-old plane, and he makes something very nice. So it's much more how you use a tool. You notice Lori's comments on Mark Miller was in my mind, it's not as much which tool he's using. It's the fact that he's conscientious about coordinating these things, making sure the minutes get out right away,
Yep.
making sure people can correct anything that's wrong. It's the user of the tool more than the tool. Sure. Now, the tools can just make you more effective.
Right.
But somebody that's good with crude tools does better than somebody with good tools that's crude.
Right. Yeah. So Mark, I know you've got a lot of experience with these things.
Well, I was going to ask you, actually, the subtleties of face-to-face communication and the value of that you brought up early on. Can you comment on the importance of that in the early period of building a team and bringing it up to speed versus the need for it on an ongoing basis once the team's sort of functioning?
Yeah, so I do think it's important to do it early, which is why we had the face-to-face kickoff where we had all 40 people, I think at that time, invited to the meeting and doing social activities to help everybody get to know each other. We did sort of round robin presentations. This is what I do. This is what I've brought to the project. Because not everybody met each other during the proposal writing phase. They all of a sudden were on this team with 40 other people. So I'd say now we're able to have, I think, really fairly effective meetings, which I can call at, like when we go to SIAM almost every year to the CSE meeting or the parallel processing meeting, and I always call a team meeting. And I'd say the first couple of those, I had to have a clear agenda, and folks were a little bit more reluctant to speak up. And now, you know, we have those meetings, and folks are much more comfortable with each other. And so there's a lot more dynamic discussion that happens, and so we can have a much more productive, shorter meeting even that gets a lot more done. So now we're starting to think about what's next for us, because we'll have project renewals, and so we'll have a face-to-face meeting in November where we talk more in detail about things like performance portability, the topic of today's panel, and things like what do the applications really need from us and you know, we'll be able to have those discussions, I think, more effectively now than we did at the beginning. And so the face-to-face is really important because, you know, right now I can look at you and I can see there's a little frown, and so you want to add something.
Because I was thinking of some piece of software I didn't get installed correctly.
Camera, software, you guys are all very distracted.
I just wanted to comment on back to the collaborative tools. My experience is that having face-to-face is absolutely crucial to team build-up in the initial phase. And that after that, once team members can understand the tones in their voices, know when people are joking versus serious on the phone, frankly, telephone plus shared whiteboard is absolutely sufficient for doing a lot of productive online interaction. I think it works great. A video, for example, I find almost completely useless.
You mentioned the fact that, you know, you've seen situations where competitors became team members, but the reality is the competitors that are my team members today are my competitors tomorrow again with something else.
That's true.
And you're constantly switching back and forth. You get to the point where you say, well, let me be honest and let me not be cutthroat. And, you know, you got to develop a little bit of a thick skin, knowing you're going to be competing with the person at the next time.
Right. So going behind people's backs is really wrong. I've really found, you know, direct communication, even if it's a message that folks don't want to hear, and this is something I've learned more in the division leader role than the fast math role. You know, direct communication is absolutely critical. Folks will listen if you're being direct and you're being honest and you're being sincere when you're trying to offer either a constructive criticism or an opposing point of view. Right? So trying to keep the emotion out of it, being open and listening to the other person's perspective, even when you're going to be collaborators or competitors tomorrow. Yeah. So you had one more question, and then I think we'll go up to the hands-on.
I wanted to ask, sometimes it's difficult to be the only woman in a team,
Mm-hmm.
and that's especially a challenge for software and for science generally. How do you view that challenge for the individual and the team?
Yeah, so it is a challenge, and a lot of it can be very personality driven. So I myself am an introvert, and so I struggle a lot, I think, sometimes for me, one of my challenges is speaking up in a meeting, particularly when I perceive I'm in a meeting with folks who are above me in the hierarchy, right? So I don't like to speak up unless I know I have something really valuable to say. And, you know, a lot of the guys around me, they'll just blather on, right? They may or may not have something valuable to say, but they're going to say it. And so it's actually, and we can talk about this more offline if you like. There are a lot of challenges that you face. And so, you know, I've set for myself, you know, some personal goals throughout the course of my career. So one of them was at a major meeting in a plenary session, I will ask a question, you know, just to kind of overcome that fear, because the more you do things like that, or whatever yours situation may be, the more you do it, the more comfortable you do it, because you'll have, maybe you'll fail sometimes and that question won't be as intelligent as you thought it was, but more often you'll succeed and you'll get more comfortable, you know, being in that dynamic. And yes, it can be a challenge because, there are a lot of women in fast math, which is wonderful for us, but in many, many other projects I've been involved with, I've been the only woman, I'm the only woman in the room, you know, yes. Let's talk about it more offline.